Today we are going to look on how we can come up with various volumes of solids. Remember what we covered the previous lesson when we talk about three-dimensional geometry. And what I talked about when we talk about the three-dimensional geometry is that when we talk about a three-dimensional figure, these are the figures whose measurement, whose surface area, and whose volume can be determined. That implies that all of these figures we are going to look up. These figures are the solids. We are going to look on the figures which are being classified under three-dimensional geometry. Now, what we are going to do when we talk about searching for the volumes of solids, we are going to look for specific figures so that we can also come in our next class to look on another figures. Now, for us to find the volume of solids, today we are going to look on the volumes of four major solids, and the first one is a cone. We are going to look on what we call the volume of a cone. We are going to look on the volume of a cone, volume of the pyramid, volume of the pyramid. Then we are going to look on what we call the volume of the prism, volume of the prism. We are also going to look on what we call the volume of the sphere, volume of the sphere. And if time allows, we are also going to look on what we call the volume of the frustum. Volume of the frustum. So these are the major figures we are going to look today on how can we find the volume of these given figures. For example, when we talk about the cone, I want us to start with the cone. And when we talk about the cone, this is what I mean. This is the cone. This is the cone I'm talking about. And if you have to be very keen when we talk about this cone, if you try to look at the base, the base we have is in form of a circle. And also now we have the perpendicular height from the base to the peak or to the vertex part of it. What we have from here up to here, we call it the height. I think you can see it from here up to here is the height. Then, if you can look at the bottom part of it, from here up to here, it is the diameter. We have the diameter of that given cone from here up to here. Meaning from here to the midist is the radius. Meaning from here up to the midist is the radius. Now this is the cone. This is our cone we are going to look on. How can you find the volume of this given cone? Now let me try to sketch it on the board. This is my cone. I'm just sketching it because I've just shown you. We have the base like this one. We have the circular base like this one. Then we have the perpendicular height from here up to here. This is our height. Then we have from here up to here, we have our radius. From that point to that point. Now, given a cone like this one, how can you find the volume of this given cone? Now, I want to remind you the volume of finding the formula of finding the volume of a cone. We have volume of this cone is given as 1/3 pi r square h. This is the formula for finding the volume of a cone given the two variables. That is the radius and the height. The radius is from here up to here, then we have the height from here up to here. Now, given the variables, then for you to find the volume of that given cone, we are going to apply the formula is equivalent to a third pi r square h. Remember in this case, pi is constant. And always our pi is equivalent to 22/7, or in terms of decimal places we have 3.142. These are the units for pi. Because pi is always constant in any mathematical calculation. Now, I want us now to put this constant. Let us assume now, in this case, in what we have here as the cone, we have been given the radius maybe to be 7 centimeter. We have our radius to be 7 centimeter. Then we have our h, which stands for the height is equivalent. The height is equivalent to maybe 21 centimeter. I'm just taking this as assumption, whereby you have been told, given a cone like this one, whose height is the same as 21 centimeter, and the radius is equivalent to 7 centimeter, then for us to find the volume of this given cone, we come and apply this formula, whereby we say the volume is equivalent to 1/3 or a third by r square. And in this case, we have the two variables, which is the radius to be 7, and we have the height to be 21. Therefore, for us to find the volume of this given cone, we are going to say the volume is going to be a third, which is 1 over 3, times pi, which is 22 over 7, times 22 over 7, times radius squared, which is 7, 7 squared is 49, then times the height, which we have been given to be 21, which we have been given to be 21. If you can cancel out, this 7 comes here 1, 7 comes here 7, 3 comes here 1, 3 comes here also 7. So our volume is going to be 22 times 7 times 7. Our volume is going to be 22 times 7 times 7, which is going to give us, those of you who have the calculators, which is going to give us, I'm just doing my calculations, times 7. Which is going to give us 1078, which is going to give us 1078 cubic centimeter, which is going to give us 1028. So this is going to be the volume of this given cone. This is going to be the volume of this given cone, given the variables, which is the height and the radius. So that is how we find the volume of some specific figures. Now, I want us to look at the next figure, which is the pyramid, And when we talk about the pyramid, this is the pyramid I'm talking about. When we talk about the pyramid. Now, if you try to look at this pyramid, if you try to look at the base of this pyramid, this base is in form of a square. Therefore, this pyramid is being called square-based pyramid. Now, there is a difference between the pyramid and the cone. If you try to look at the pyramid, the base is either in the form of a square or in the form of a rectangle. But if you try to look at the cone, the base is in the form of what? A circle. That is the major difference. Now, when we talk about this pyramid, how can we find the volume of a pyramid given the measurements of the base and the height? Now, the height is from the middle of the square up to the vertex. Now, that is what we have. So we have the square-based pyramid. How can we find the volume of the pyramid? And we have the volume of the pyramid. When we talk about the pyramid, the volume is the same as 1 over 3 or a third. We have PA, which stands for base area times height. That is what it means for us to talk about finding the volume of given pyramid. We have a third, base area times height. Now, the reason we talk about the base area times height is because sometimes the base can be in the form of a square, sometimes it can be in the form of what? A rectangle. So you find the base area, then you have a third base area times height. Let me try to sketch my pyramid here. I want to sketch just my pyramid. Let us assume that is the pyramid, and in this pyramid we have also the height from here to the middle of them. We have this one to be the height, Now let us assume our height is given, which is equivalent to 10 centimeter. Then we have from here to here the 4 centimeter. Then we have this one to be 4 centimeter. Maybe this is A, P, C, D. Then we have feet. Now, given what I've just drawn, I've translated what I have in the board. So I've just sketched, but this is the real pyramid. Now, for us to find the volume of this pyramid, given that the measurement from here up to here is 4, which is equivalent from here up to here, which is 4, because we have said this is a square-based pyramid. Then we have the height from here up to here to be able to be what? 10 centimeter. Then, how can you find the volume of this given figure. How can we find the volume of this given figure, which is in the form of a pyramid? We say our volume for this pyramid is going to be, our volume is going to be a third, which is 1/3. Then base area times the height. Let us start with the base area. We have said the base of this pyramid is in the form of a square. And how do we find the surface area of a square? It is length times length, which is equivalent to length square. So the base area is going to be 4 times 4, which is equivalent to what? 16, which is equivalent to 16. Therefore, the area of this given, let us say this one is 12. Let us say the height is 12 centimeter. Now, if the height is 12, then our volume for this specific pyramid is going to be a third times the base area, and in this case our base area is 4 times 4, which is 16. So times 16, then times the height from here up to here, which we have expected to be 12. Then times 12. This comes here 1, comes here 4. So we are going to have 16 times 4, which is going to give us what? 16 times 4. 64, which is going to give us 64 cubed centimeter, which is going to give us 64 cubed centimeter. So the volume of this given pyramid, is going to be 64 cubed centimeter. That is how we can find the volume of a pyramid. Given the specific measurements, which we call the variables. Now, I want us to look on how can you find the volume of a prism. How can you find the volume of a prism? Now, when we talk about a prism, this is what we have as a prism. This is our prism now. This is the shape of a prism. Now, for us to find the volume of this given prism, we will say, for us to find the volume of our prism, the volume is the same as area of cross section times the length. This is how we find the volume of a prism. Whereby we say the volume is the same as area of the cross section of that given prism, then times the length. Now, how can you know that this is the cross section and this is the length? If I put my prism like this one, from here up to here, what we have here as the plane we have here qualifies to be the cross section. Then from here up to here, we call it the length. If I can try to translate this one, if I can try to draw something like this one, let us assume this is what we have. Then we can have this one coming like this one. Then we have this one. Then we have this one and this one. Now, I've just tried to draw what we have here. Now, let us assume from here up to here, the 10 centimeter, which is equivalent from here up to here, which is 10 centimeter. Then, from here up to here, which is equivalent from here to here, is this is 20 centimeter. This is also 20 centimeter. Then we have then from here up to 76 centimeter. This is what I have. In fact, what I've drawn is what I have here. Whereby from here up to here with 20 centimeter, from here up to here 20 meter, which is the same as from here up to here. From here up to here is from this point to this point, which is equivalent to what? 10 centimeter. Then from here up to the other corner is 6 centimeter. That's what I have. If I can extract the cross section, our cross section is going to be like this one. Whereby from here is 6, this is 20, this is 20 centimeter, this is 6 and 20 centimeter. And remember, we have our 90 degrees there, which makes the cross section to be a right angle triangle, which makes the cross section to be a right angle triangle. Therefore, for us to find the volume of this given prism, which I'm having, for us to find the volume of this given prism, then we are going to say the volume is the same as the surface area of the cross section times the length. And for us to find the surface area of the cross section is this one, the surface area of this one. This is a right angle triangle, we say it the same as a half times space, which is 6, times height, which is 20. This come here 1, come here 10, this will give us what? 60 square centimeter. 60 square centimeter. So this is going to be the area of the cross section. This is going to be the area of the cross section. Therefore, for us to find the volume of this prism, we are going to say the volume of this prism is the same as area of the cross section times the length. Length is from here up to here, which is 10. We have the cross section to be 60. Therefore, the volume of that given prism is going to be 60, which is the area of the cross section, times the length, which is 10. Times the length, which is 10, which is going to give us what? 600, which is going to give us 600 cubic centimeter, which is going to give us 600 cubic centimeter. So this is going to be the volume of that given prism. So that is how we find the volume of the cone. We have broken the volume of the cone and how you can come up with the volume of the cone, whereby we have the formula to be volume is the same as a third pi r square h. Therefore, when we talk about the pyramid, the formula is almost the same, but in this case pi r square we replace with the base area. Therefore, the formula for finding the volume of a pyramid is a third base area times height. Now, when we move to the prism, I'm saying for us to find the volume of a prism, it is the same as area of the cross section times the length. And we are going to look on how we can find the area of the sphere and the area of the frustum in our next lesson. So in our next lesson, we are going to look how can you find the volume of a sphere. Then, how can you find the volume of the frustum before we move to the finding the volume of other figures.